Welcome to this quiet space, a gentle pause in the ceaseless rhythm of your day, wherever you are, whatever time it might be for you, morning, noon, or the hush of deep night. I invite you to settle in. There's no rush here, no need to seek quick answers or grasp at fleeting thoughts. This is a sanctuary for your mind, a tranquil haven where curiosity can softly unfurl, like a delicate blossom opening to the morning sun. You are safe here, free to simply be, to breathe, and to let your imagination wander through the grand tapestry of our universe. We'll explore profound ideas, not to memorize them, but to feel them, to let them wash over us like a calming tide, perhaps even lulling us into a peaceful stillness or guiding us gently towards sleep. This journey is one of quiet contemplation, a whispered exploration of the cosmos, designed only for your relaxation and wonder. So, let us begin our gentle wandering, not just through the vast stretches of space that we can see with our eyes, but back through time itself, to a moment when time, as we know it, may have just begun. We'll speak of something truly immense, something that defines our very existence, yet remains shrouded in a comforting veil of mystery, the Big Bang. Perhaps you have heard this phrase before, whispered in documentaries or glimpsed in textbooks. The Big Bang. It sounds dramatic, doesn't it? Like a sudden, thunderous clap or a brilliant burst of light, and in a way, it was. But it was also something far more subtle, far more profound than any simple explosion. Imagine, if you will, not an explosion in space, but an explosion of space itself. Everything that is, everything that ever was, and everything that ever will be, contained in a point so impossibly tiny, so infinitesimally small, that our minds struggle to grasp it. A seed, perhaps, of unimaginable density and heat, holding the blueprint for galaxies, stars, planets, and even the very breath you are taking right now. Think of it as the universe's earliest morning, a dawn unlike any other. Before this moment, there might have been nothing, or perhaps something we cannot yet comprehend. Science, in its quiet pursuit of truth, suggests that roughly 13.8 billion years ago, this remarkable beginning occurred. It wasn't an event that happened at a particular spot in a pre-existing void, like lighting a match in a dark room. No, it was the very fabric of space and time unfolding from that singularity, expanding outward in every conceivable direction, carrying everything with it. It's a concept that invites quiet wonder. What does it mean for space itself to expand? Picture a balloon, not with dots on it that are moving away from a central point, but with tiny points of light embedded in its surface. As you inflate the balloon, these points of light move further apart from each other. None of them are at the center of the expansion. Rather, every point sees every other point receding from it. This is a gentle metaphor, a soft way to visualize the grand cosmic ballet that began with the Big Bang. The universe didn't rush out into empty space. It created the space as it expanded. In those first fleeting moments, shorter than the blink of an eye, the universe swelled from something smaller than an atom to something the size of a grapefruit. This period, known as inflation, was a burst of super rapid expansion, a cosmic sigh that smoothed out the universe, making it remarkably uniform and flat, like the surface of a calm pond. It's a subtle idea, inflation, almost like a whisper in the early cosmic darkness. But it resolved many puzzles that scientists pondered about the universe's grand design. It allowed for tiny quantum fluctuations, like ripples on that pond, to be stretched across vast cosmic distances, eventually growing into the seeds of future galaxies. Imagine this early universe, a place of inconceivable heat and energy. So hot, in fact, that matter as we know it couldn't exist. There were no stars, no planets, no atoms, just a shimmering, swirling soup of fundamental particles, quarks and leptons, photons and gluons constantly colliding, being created and annihilated in a dance of pure energy. It was a chaotic symphony, yet one that held the promise of everything to come. As the universe continued its gentle, continuous expansion, it began to cool. Think of a hot oven door slowly opening, letting the warmth dissipate into the room. This cooling allowed for new possibilities to emerge. Quarks began to bind together, forming the first protons and neutrons, the building blocks of atomic nuclei. This was a significant step, a moment when the formless energy began to take on structure, a quiet crystallization from the primordial soup. For hundreds of thousands of years, the universe remained opaque, a thick, dense fog of plasma, photons, particles of light, couldn't travel freely. They were constantly scattering off the free-floating electrons and protons, like light trying to pierce through a dense cloud on a foggy morning. So, even though light existed, the universe itself was dark, shrouded in its own intense glow. It's a strange thought, isn't it? Light, yet darkness. But it was a vibrant darkness, teeming with potential. Then came a moment of profound transformation, often called recombination or the Dark Ages, though it led to the first light. As the universe expanded further and cooled to about 3,000 Kelvin, the free electrons were finally able to combine with the protons and helium nuclei, forming the first neutral atoms, hydrogen and helium. This seemingly simple event was monumental. With the electrons now bound within atoms, the photons were free to travel unimpeded. The universe suddenly became transparent. And this freedom of light, this ancient, liberated glow, is what we now call the cosmic microwave background, or CMB. It's the oldest light in the universe, a faint afterglow of the Big Bang, still permeating every corner of space. Imagine listening to a very, very old echo, a soft whisper from the very beginning of everything. This is what the CMB is to cosmologists, a gentle, ambient hum of radiation, telling us stories of a time long, long ago. It's not something you can see with your eyes, but sensitive instruments can detect it, map its subtle variations, and from these tiny temperature differences, we can reconstruct the story of the early universe. It's like finding a faded, ancient photograph, offering clues to a distant past, inviting us to peer closely and feel the vastness of time. This ancient light, now stretched and cooled by billions of years of cosmic expansion, appears to us as microwaves. It's everywhere, always, a subtle warmth just above absolute zero. If you could tune into it, you might feel a faint embrace, a distant connection to that very first moment. It is empirical evidence, a tangible whisper, that the Big Bang was not just a theory, but a profound event that set the stage for all that is. It tells us that the universe was once much hotter, much denser, and that it has been expanding and cooling ever since. And what happened after this great liberation of light? The universe entered a period known as the Dark Ages again, a misnomer, as it was a time of immense formation. For hundreds of millions of years, there were no stars, no galaxies, just vast clouds of neutral hydrogen and helium, gently drifting in the expanding cosmos. But within these clouds, gravity, that quiet, persistent sculptor, was at work. In the regions where the early universe had slightly higher densities, those tiny ripples stretched by inflation gravity slowly, inexorably, pulled matter together. Imagine colossal, invisible hands gently kneading the cosmic dough, gathering it into clumps. Over immense stretches of time, these clumps grew larger and denser. The force of gravity, subtle at first, became more powerful as more matter accumulated. These growing clouds became the cradles for the universe's first stars, the true pioneers of light in the vast cosmic night. When these first stars ignited, they were colossal, brilliant, and short-lived. They burned through their fuel at an astonishing rate, radiating intense ultraviolet light that reionized the neutral hydrogen around them, effectively ending the dark ages and illuminating the universe once more. This era, known as Rionization, was another pivotal moment, a cosmic awakening where the universe began to shine with the light of newly born suns. From these first stars came the building blocks of complexity. Inside their fiery hearts, through a process called nucleosynthesis, lighter elements like hydrogen and helium were forged into heavier ones, carbon, oxygen, iron, the very elements that make up our bodies, our planet, and all the wonders around us. When these massive first stars reached the end of their lives, they exploded in spectacular supernovae, scattering these newly created heavier elements across the nascent universe. These scattered elements then became the raw material for the next generation of stars, and the next, and the next. This gentle cosmic recycling, this endless cycle of birth, life, and death, led to the formation of galaxies. Over billions of years, vast collections of stars, gas, and dust spiraled and danced together, drawn by the invisible hand of gravity, creating the magnificent structures we observe today, like our own Milky Way galaxy. It's a story of profound simplicity and astonishing complexity, all flowing from that singular beginning. And yet, for all that we know, so much remains beautifully, wonderfully unknown. The Big Bang Theory describes what happened from that earliest moment of expansion, but it doesn't fully explain why it happened, or what was before it. These questions invite us to linger in the realm of deep contemplation. What if the Big Bang wasn't the absolute beginning, but merely a phase in a larger, eternal cycle? Some theories propose a cyclic universe, where our universe is one in an endless series of expansions and contractions, like a cosmic breath in and out. Others suggest a multiverse, a vast ocean of universes, where our own is just one bubble among countless others, each with its own laws of physics, its own beginning, its own story. Imagine the quiet hum of existence, not just here, but in infinite other realms, each breathing its own unique tune. Then there is the concept of quantum gravity, a grand pursuit in physics that seeks to unite the very small with the very large. At the energies and densities of the early Big Bang, the laws of gravity as we understand them break down. We need a new framework, one that blends Einstein's general relativity with the strange, probabilistic world of quantum mechanics. Theories like loop quantum gravity or string theory whisper possibilities of what might have been, envisioning space-time as a woven fabric, or tiny vibrating strings, or even a universe without a true beginning in the conventional sense, but a kind of bounce from a previous state. Consider the notion of a universe with no boundary, as proposed by Stephen Hawking. If the universe has no boundary in space and time, then the question of what happened before the Big Bang becomes meaningless, much like asking what is north of the North Pole. It suggests a universe that is self-contained, complete in its own existence, without needing an external cause or an initial push. It's a gentle, philosophical turn, inviting us to accept the inherent completeness of the cosmos, a universe that simply is. These aren't questions that demand immediate answers, nor are they meant to stir up intellectual debate. Instead, they are invitations to let your mind float freely, to explore the edges of our knowledge, and to find peace in the vastness of what we don't yet comprehend. It is enough to simply rest with the idea that our universe, This incredible, intricate dance of matter and energy began in a moment of profound transformation. Feel the quiet expansion, the gentle unfurling of space that began so long ago and continues even now. Every galaxy you see, every star that twinkles in the night sky, every atom within you is a descendant of that singular event. You are a part of that story, a tiny yet significant piece of the cosmic tapestry. Let this thought settle softly within you. There is beauty in the mystery, comfort in the vastness, and a deep sense of belonging in knowing that we are all woven from the same ancient cosmic threads: the Big Bang, the expansion, the cooling, the formation of light, the birth of stars and galaxies. It is an epic, soothing narrative that plays out around us, within us. As we gently drift through these concepts, allow your breath to deepen, to match the quiet rhythm of the universe's expansion. Inhale the wonder. Exhale any lingering tension. The story of the cosmos is one of continuous creation, a perpetual becoming, and you, in this very moment, are part of that magnificent flow. The universe began, and it continues. It unfolds, ever so gently, revealing its secrets one whispered discovery at a time. We are here now to simply listen to that ancient hum, to feel the echoes of its dawn, and to find a profound sense of peace in its boundless journey. This quiet journey has only just begun. We've taken a first soft step into the immensity of time and origin. There are so many more layers to explore, so many more gentle mysteries waiting to be contemplated as we continue our path through the scientific wonders that soothe and inspire. For now, let the idea of the universe's grand beginning cradle your thoughts, gently, as the faint echoes of the Big Bang gently recede, leaving a soft hum in the silence of your mind. Let us turn our gaze to another profound mystery, one that touches every moment of your existence. Time. What is time? Really, it feels so fundamental, so constant. Yet, it is perhaps one of the most elusive concepts in all of science. We measure it with clocks, mark it with seasons, and feel its relentless flow, moving always forward, never backward. But is that all it is? Imagine, for a moment, that time is like a river. It flows, always in one direction, carrying everything along with it. You are a leaf upon this river, gently carried from one moment to the next. The past is the water that has already flowed beneath you, gone forever. The future is the stretch of river yet to be explored, a mystery just around the bend. And the present, this very instant, is the tiny point where you currently are, suspended between what was and what will be. This analogy feels intuitive, doesn't it? It reflects our everyday experience. We remember yesterday, anticipate tomorrow, and live in the now. But science, in its quiet contemplation, suggests that the river of time might be far more complex, far more nuanced than we intuitively perceive. Perhaps the most revolutionary idea about time comes from Albert Einstein. He didn't see time as a separate, unchanging river, but as intricately woven with space, forming a single, flexible fabric called space-time. Imagine a vast, invisible blanket stretching across the entire universe. This blanket is space-time. When something massive, like a star or a planet, rests on this blanket, it creates a dip, a curve in the fabric, and this curve, this gentle warping, is what we perceive as gravity. But here's where it gets truly fascinating. This warping doesn't just affect space, it affects time too. If you are near a massive object where space-time is more curved, time actually passes a tiny bit slower for you than it does for someone far away in a less curved region. This phenomenon is called time dilation. It's not just a theoretical idea. It's been proven with incredibly precise clocks. For instance, the clocks on GPS satellites orbiting high above Earth run slightly faster than clocks on the ground. If we didn't account for this tiny difference, your GPS would be wildly inaccurate. So, in this gentle dance of space-time, time is not an absolute, unwavering beat. It's relative. It stretches and compresses, gently bending around massive objects. It's like different currents in our river of time, some moving a little slower, some a little faster, depending on the gravitational landscape they are flowing through. This fluidity of time can be a deeply calming thought. It suggests that our experience of time is personal, subtly influenced by our cosmic surroundings. We are not merely passive passengers on a rigid timeline. Rather, we are immersed in a dynamic, responsive flow. But what about the direction of time? Why does the river always flow forward, from past to future? Why can't we remember tomorrow, or reverse a mistake we made yesterday? This is known as the arrow of time, and it's one of the deepest puzzles in physics. One of the most widely accepted explanations for the arrow of time comes from thermodynamics, specifically the second law of thermodynamics. This law states that in any isolated system, entropy, a measure of disorder or randomness, always tends to increase over time. Think of a neatly stacked pile of Lego bricks. If you knock it over, the bricks scatter, becoming more disordered. You don't naturally see scattered bricks spontaneously reassemble into a neat pile. That would decrease entropy. The universe, as a whole, is always moving towards greater disorder, a more spread out, uniform state. Imagine a drop of ink falling into a glass of clear water. Over time, the ink spreads out, dissolving into the water until the entire glass is uniformly colored. You never see the ink spontaneously recollect into a neat drop. This spreading, this mixing, is an increase in entropy. And this irreversible process, this tendency towards greater disorder, seems to be what gives time its one-way street. The universe is constantly moving from a state of lower entropy, more ordered, like the very hot, dense, initial state of the Big Bang, to a state of higher entropy, more spread out, more uniform, like the vast, cool universe we see today. So, the arrow of time, the relentless forward march, might simply be the universe unwinding, like a cosmic clock running down, slowly approaching a state of maximum entropy, where everything is perfectly uniform and nothing much can happen anymore. This ultimate state is sometimes called the heat death of the universe, a distant, tranquil end where all energy is evenly distributed, and there are no temperature differences, no gradients to drive any processes. It's a vast, serene equilibrium, a cosmic stillness. This concept can be surprisingly calming. If time's direction is tied to this grand cosmic unwinding, then every moment, every breath, every gentle shift you feel is part of an inevitable, natural process. There's a deep peace in accepting this flow, in understanding that your own existence, with its own small entropy changes, is a tiny part of the universe's grand narrative. Yet, this explanation still leaves some questions gently lingering in the mind. What if time is not truly a fundamental reality, but an emergent property, something that arises from more basic interactions at a deeper level? Some physicists explore the idea that at the most fundamental, quantum level, there might be no such thing as time as we experience it. They suggest that time could be an illusion, a construct of our consciousness, or a statistical average of countless, timeless quantum events. Imagine a vast, intricate tapestry. From a distance, you see patterns, stories, a clear flow. But if you zoom in, closer and closer, to the individual threads, the knots, the tiny fibers, perhaps the flow disappears, replaced by an intricate, timeless structure. This is a very deep, very subtle idea, hinting that our familiar river of time might be just one way of perceiving a deeper, more profound reality. Consider theories of quantum gravity, which seek to unify the rules governing the very small quantum mechanics with the rules governing the very large general relativity. In some of these theoretical frameworks, such as loop quantum gravity, time doesn't exist as a continuous, smooth flow. Instead, it might be granular, existing in tiny, discrete chunks or quanta. Much like energy comes in discrete packets. If this were true, then the smooth flow of time we perceive would be an approximation, like seeing a continuous motion picture made up of thousands of still frames. Each frame is distinct, but when played quickly, they create the illusion of smooth movement. This idea can be profoundly liberating. If time is not what we think it is, then perhaps our anxieties about its relentless passage, our regrets about the past, or our worries about the future are rooted in a limited perception. To truly live in the present, to fully embrace the now, might be more aligned with the universe's deepest nature. There is also the concept of the block universe, a philosophical interpretation stemming from Einstein's relativity. In this view, past, present, and future all exist simultaneously, like slices of a cosmic loaf of bread. Your journey through time is simply your consciousness moving through these pre-existing slices. It's not that the future is created as we go along, rather, it's already there, waiting to be experienced. Imagine a book. All the chapters, from beginning to end, already exist within its pages. When you read it, you move sequentially from one page to the next, experiencing the story linearly. But the entire story, the entire book, exists as a complete entity in a block universe. All moments of space-time exist as a complete, unchanging whole. This can be a deeply peaceful thought. It suggests that nothing is ever truly lost. Every gentle moment, every whispered thought, every loving embrace from your past still exists, perfectly preserved within the fabric of space-time. The future, too, holds its moments, waiting for your consciousness to arrive. It removes the urgency, the fleeting nature we often associate with time, and replaces it with a sense of eternal presence. But if all moments exist simultaneously, does that mean free will is an illusion? This is a question that philosophers and scientists have pondered for centuries, and it ties back to the profound nature of time. There are no easy answers, and in this quiet space, we don't seek to find them. Instead, we simply let the questions gently float, like clouds drifting across an endless sky, admiring their form without needing to capture them. Let your mind drift through these possibilities. Time as a river, time as a dimension of space-time, time as an arrow of increasing disorder, time as an illusion, time as discrete quanta, time as a complete block. Each perspective offers a unique lens through which to view reality, a different flavor of cosmic wonder. Perhaps the most soothing aspect of contemplating time is recognizing its sheer immensity. From the first moments of the Big Bang, 13.8 billion years have unfolded, a staggering duration that our human minds can barely comprehend. Stars have been born and died, galaxies have formed and merged, planets have circled their suns countless times, and within this grand sweep of cosmic time, your own life, a precious flicker, is unfolding. This vastness can be deeply calming. It puts our small worries and fleeting moments into a grander perspective. The anxieties of a single day, the pressures of a single week, become tiny ripples on the surface of an ancient, immeasurable ocean. In the face of cosmic time, we are invited to release the grip of urgency, to find solace in the slow, deliberate rhythm of the universe. And what about the end of time? If such a thing exists, if the universe continues to expand and cool indefinitely, gently approaching that state of maximum entropy, what would that feel like? A universe where all stars have burned out, all black holes have evaporated, and matter is so thinly spread that nothing can interact anymore. It would be a time of ultimate stillness, a cosmic quietude beyond imagining, perhaps a state of perfect peace, where the dance of energy has finally ceased, leaving behind only the soft hum of residual radiation. This is a very, very distant future, a vision that dissolves into the mists of unimaginable eons. It's not a thought to fear, but one to gently consider, a final frontier of cosmic tranquility. So, as you rest, let your awareness expand beyond the ticking of clocks, beyond the rising and setting of the sun. Feel yourself immersed in the true nature of time, not as a tyrant rushing you forward, but as an integral part of the universe's gentle unfolding. You are part of eternity, a brief, beautiful expression of the cosmos experiencing itself. Perhaps in this deeper understanding, you can find a profound sense of presence. The past is a rich tapestry of memory, held gently within the fabric of space-time. The future is an open possibility, unfolding moment by moment. And the present, this precious now, is where all of existence truly resides. Allow any thoughts about deadlines or regrets, any anxieties about what comes next, to simply drift away. They are but tiny shadows on the vast, luminous canvas of cosmic time. Let the quiet contemplation of time's mystery soothe your mind, calming the currents of your thoughts. In this stillness, you are timeless. You are boundless. You are simply here, now, breathing with the universe. Having gently considered the vast, flowing nature of time, let us now turn our attention to another fundamental aspect of our existence, one that seems utterly empty, yet holds unimaginable potential: the vacuum. When you think of a vacuum, your mind might conjure images of deep space, of vast expanses between stars and galaxies, utterly devoid of anything, just empty, cold, dark nothingness. But is it truly nothing? Science, in its gentle probing, reveals a far more vibrant and bustling reality, even in what seems to be the most desolate corners of the cosmos. Imagine, if you will, the deepest, darkest point in space you can conceive, far from any planet, any star, any galaxy, just boundless, empty void. Our intuitive sense tells us this must be utter emptiness. But according to quantum mechanics, the laws that govern the very small, this empty space is anything but. It is, in fact, teeming with activity, a silent, swirling ocean of potential, constantly fizzing with fleeting phenomena. This is the concept of the quantum vacuum. It's not just nothing, it's a dynamic medium, a stage upon which particles are constantly, spontaneously, popping into and out of existence. These are virtual particles, appearing in pairs, a particle and its antimatter twin, only to annihilate each other almost immediately. Think of it like a perfectly still pond. Yet if you watch very closely, you might see tiny ripples appearing and disappearing on its surface, almost too fast to truly grasp. These ripples are the fleeting existence of virtual particles. Why does this happen? It's a consequence of the Heisenberg uncertainty principle, a beautiful and profound idea in quantum mechanics. This principle tells us that we cannot simultaneously know with perfect precision certain pairs of properties, such as a particle's position and its momentum, or, crucially for the vacuum, its energy and the amount of time it exists. This means that for very, very short periods of time, energy can borrow itself from the vacuum, momentarily manifesting as these virtual particle pairs, as long as they disappear before they violate the universe's fundamental laws. It's like a cosmic loan system, where debts are always immediately repaid. This constant, ephemeral dance of virtual particles means that even in the most absolute vacuum, there is an inherent, irreducible energy, the zero-point energy or vacuum energy. It's the lowest possible energy state a quantum field can have, even at absolute zero temperature, where all thermal motion has ceased. It's the residual hum of the universe, always present, always active, never truly silent. Consider the implications. If the vacuum is not empty, but filled with this fluctuating energy, this subtle vibration, then the very fabric of space is alive. It's like a vibrating canvas, constantly moving, constantly shifting, even when nothing real appears to be happening. This energy, though usually imperceptible to our senses, has real, measurable effects. One famous example is the Casimir effect, where two uncharged, parallel metal plates placed very close together in a vacuum will actually push towards each other with a tiny force. This is because between the plates, only certain wavelengths of virtual particles can exist, while outside, all wavelengths are possible, creating an imbalance in vacuum energy that pushes the plates together. It's a subtle whisper of the vacuum's hidden power. This understanding of the vacuum redefines our notion of nothing. It tells us that even apparent emptiness is rich with potential, a latent source of creation and annihilation. It suggests that the universe, even in its quietest corners, is never truly passive. It is always vibrating, always bubbling, always in a state of subtle, dynamic equilibrium. This can be a deeply calming thought. If nothing is so full of something, then perhaps there is no true emptiness anywhere. Even in moments of quiet solitude, when you feel utterly still, the quantum vacuum energy within and around you continues its silent dance. You are part of this fundamental cosmic hum, connected to the very fabric of existence at its most basic level. But the vacuum also holds another grand mystery, one that connects it directly to the expansion of our universe. This is the enigma of dark energy. As we discussed, the universe began with the Big Bang and has been expanding ever since. For a long time, scientists believed that gravity, pulling things together, would eventually slow this expansion down, perhaps even causing the universe to collapse back in on itself in a big crunch. However, in the late 1990s, observations of distant supernovae revealed something astonishing. The universe's expansion isn't slowing down, it's actually accelerating. It's speeding up, like a car, with its foot on the gas pedal. This was a profound shock, a revelation that pointed to a mysterious force counteracting gravity, pushing everything apart. Scientists call this mysterious force dark energy. And one of the leading hypotheses for what dark energy might be is precisely the energy of the vacuum itself. If the quantum vacuum inherently possesses this zero-point energy, and if this energy exerts a negative pressure, a pushing apart force, then it could be the engine driving the universe's accelerating expansion. Imagine our cosmic balloon analogy again. Instead of just inflating, imagine that the very fabric of the balloon itself is subtly stretching from within, pushing the points on its surface further and further apart at an ever-increasing rate. This intrinsic energy of space, the vacuum energy, would be the force causing this accelerated stretching. This is a beautiful, if unsettling, idea. It implies that the empty space between galaxies is not merely a passive void, but an active, energetic component of the universe, constantly generating the force that pulls everything apart. It means that the more space there is, the more dark energy there is, leading to an ever faster expansion. The challenge, however, is immense. When physicists try to calculate the theoretical value of vacuum energy based on quantum mechanics. They arrive at an outrageously large number, something like 120 times larger than what observations of dark energy suggest. This is the most infamous discrepancy in all of physics, a colossal mismatch between theory and reality. It's like predicting the weight of a feather and getting the weight of the entire Earth. This suggests that our understanding of the quantum vacuum or dark energy, or both, is still profoundly incomplete. Yet, this uncertainty does not diminish the wonder. Instead, it deepens it. It highlights the vast, unexplored territories of knowledge that lie before us. It reminds us that even in our most advanced scientific models, there are whispers of deeper truths, subtle hints of a reality that is far more intricate and surprising than we can currently grasp. So, as you rest, let your mind gently consider this active emptiness. The space around you, seemingly still and silent, is in fact a dynamic, energetic field. It's a place where particles are born and die in an instant, where energy hums at its lowest possible state, and where a mysterious force might be subtly pushing the very fabric of the universe apart. There's a deep peace in this thought. It tells us that even in moments of perceived stillness or absence, there is always presence, always potential, always a gentle, underlying hum of existence. The quietest spaces are often the most profound. This understanding can help us reframe our own experiences of emptiness. When you feel a moment of quiet, a space between thoughts, or even a sense of inner void, perhaps it is not an absence to be filled, but a quantum vacuum within you, alive with unseen potential, brimming with the raw material for new thoughts, new feelings, new moments of being. Allow yourself to sink into this idea. You are floating in a cosmos that is never truly empty, a universe where nothing is endlessly fascinating. Let the gentle hum of the quantum vacuum, this subtle, omnipresent energy, soothe your mind and body. It is the very essence of potential, flowing all around you, supporting all that is. The silence that surrounds you right now is not barren. It is rich, pregnant with possibility, alive with the dance of virtual particles and the subtle push of dark energy. This understanding can bring a profound sense of calm, a feeling of being cradled by the universe itself, even in its most seemingly desolate stretches. We don't need to understand every detail, every equation. It is enough to simply contemplate the beauty of this concept, that the vacuum, the ultimate nothing, is in fact a vibrant field of energy, constantly in motion, constantly creating. It reminds us that life, even in its most basic forms, is a continuous unfolding, a perpetual emergence from the subtle vibrations of reality. Let this gentle, continuous creation resonate within you, easing your thoughts, inviting a deeper sense of relaxation. You are breathing in a universe that is never truly still, never truly silent, even in its deepest, darkest corners. As the gentle hum of the quantum vacuum fades into the backdrop of your awareness, let us now embark on a truly mind-bending journey, one that pushes the boundaries of our imagination, the concept of the multiverse. Could our universe, with all its galaxies, stars, and the very ground beneath your feet, be just one amongst an infinite tapestry of others? This idea, once relegated to the realm of science fiction, is now a serious area of contemplation for many physicists. Imagine, if you will, not just one vast ocean of existence, but an endless sea of bubbles, each bubble a self-contained universe, perhaps with its own unique laws of physics, its own history, its own beginning and end. Our universe, the one we inhabit, would be just one of these countless bubbles, gently expanding, living out its cosmic story. This notion can be deeply soothing, for it suggests an almost infinite abundance, a boundless creativity inherent in reality. If there are countless universes, then the possibilities for existence are truly limitless, far beyond anything our single universe could ever contain. One of the primary ways the idea of a multiverse arises is from the very theory we discussed earlier, cosmic inflation. Remember that brief, incredibly rapid burst of expansion in the earliest moments of our universe, smoothing it out and setting the stage for everything that followed? Well, some models of inflation suggest that it might not have been a one-off event. Instead, inflation might be an eternal process, continuously spawning new pocket universes like ours. Imagine a giant, ever-expanding foam. Each bubble in the foam is a separate universe. As this foam expands, new bubbles are constantly forming, detaching from the main foam and inflating on their own. Our universe would be one such bubble, a calm pocket in a vast, turbulent, eternally inflating sea. In this eternal inflation scenario, inflation never truly stops everywhere. It might end in certain regions, forming a universe like ours, but it continues indefinitely in others, perpetually creating new universes. This can be a deeply peaceful thought. It suggests that creation is an ongoing, boundless process. There is no ultimate end to existence, no final curtain call for reality. Instead, it is an endless symphony of beginnings, a continuous cosmic unfolding, where new realms are always coming into being. It removes the pressure of our single universe being the only one, allowing for a sense of profound liberation and infinite possibility. Another fascinating avenue leading to the multiverse concept comes from string theory and its more expansive cousin, M theory. These theories propose that the fundamental building blocks of the universe are not point-like particles, but tiny, vibrating strings of energy, or even higher dimensional membranes often called brains. The way these strings or brains vibrate, curl up, or interact dictates the properties of the particles and forces we observe. Now here's where the multiverse comes in. String theory requires many extra dimensions beyond the three spatial dimensions and one time dimension we experience. These extra dimensions are often thought to be curled up incredibly tightly, too small for us to perceive. However, M theory suggests that our entire universe might be a single brain floating within a higher dimensional bulk space. Imagine sheets of paper floating in a vast, unseen room. Each sheet is a universe. Occasionally, these sheets might interact, gently brushing against each other, or even colliding. Such interactions could potentially trigger events like our Big Bang, a cosmic collision giving birth to a new expanding universe. This brain multiverse suggests that our universe is not alone, but one among many parallel brains, coexisting in a larger, hidden reality. This can evoke a sense of profound wonder. It suggests that beyond our familiar three dimensions, there might be other, unseen realms, rich with their own intricate geometries and hidden possibilities. Our reality, as vast as it seems, might be just one thin slice of a much grander, multi-dimensional existence. It invites a quiet contemplation of what might lie beyond the veil of our perception, a gentle expansion of our understanding of what space truly means. Then there is the intriguing idea born from quantum mechanics itself, the many worlds interpretation. This interpretation suggests that whenever a quantum measurement is made, or a quantum event with multiple possible outcomes occurs, the universe splits into different branches, with each branch representing a different outcome. Imagine a simple choice: you flip a coin. In one universe, it lands heads. In another, a completely separate universe, it lands tails. Every decision, every quantum fluctuation, every tiny probabilistic event leads to a branching of reality, creating an infinite number of parallel universes, each representing a slightly different version of events, a different path taken. This interpretation can be deeply comforting in its vastness of possibilities. If every choice, every potential outcome, plays out in some parallel reality, then perhaps nothing is truly lost. Every path not taken, every what if, exists somewhere, gently unfolding in its own separate timeline. It implies an almost boundless creativity within the quantum realm, a continuous branching of existence that leaves no stone unturned in the cosmic play. However, it also raises profound questions about consciousness and the nature of reality. Are you splitting into infinite versions? Do these parallel yous truly exist? These are not questions for us to answer definitively in this tranquil space. Instead, they are invitations to simply ponder the incredible depth and mystery of quantum reality, to let these ideas gently swirl in your mind like distant stars in a cosmic night. The multiverse concept also addresses what some call the fine-tuning problem. Our universe seems incredibly finely tuned for life. If fundamental constants of physics like the strength of gravity, the mass of an electron, or the precise value of dark energy were even slightly different, life as we know it would be impossible. For instance, if gravity were a tiny bit stronger, stars would burn out too quickly. If it were weaker, galaxies wouldn't form. It's like our universe hit the cosmic lottery with its specific set of physical laws. In a multiverse scenario, this fine-tuning becomes less miraculous. If there are countless universes, each with a slightly different set of physical laws or constants, then it's simply a matter of probability that at least one of them would have the right conditions for life to emerge. We just happen to find ourselves in one of the lucky universes, like finding the one habitable planet in a vast array of possibilities. It's not that it was designed for us, but simply that we exist where conditions allow us to exist. This perspective can be deeply humbling and liberating. It reminds us of our unique, yet perhaps not solitary, place in the grand scheme of things. It suggests that the universe's generosity for life might extend far beyond our single cosmic bubble, into realms we can only softly imagine. What are the implications of contemplating a multiverse? It encourages us to release the rigid grip of a singular reality. It opens our minds to realms beyond our immediate perception, to possibilities that stretch far beyond the limits of our current understanding. It invites a sense of humility, knowing that our vast universe might be but a tiny drop in an infinite cosmic ocean. This idea of infinite universes can be deeply peaceful. It suggests an endlessness, a boundless creativity inherent in existence. There is no finality, no ultimate end to the cosmic story. Instead, there is a continuous, gentle unfolding, a perpetual emergence of new realities, new forms, new possibilities. Let your imagination gently expand beyond the familiar into this vast sea of universes. Feel the sense of immense scale, of boundless potential. Your very existence, your consciousness, is a tiny flicker within one of these countless cosmic bubbles, yet it is profoundly connected to the entire unimaginable expanse. In this quiet contemplation, allow any boundaries of your own thought to soften, to dissolve. There is more than meets the eye, more than our senses can currently perceive, more than our most powerful telescopes can glimpse. The universe, or perhaps the multiverse, is an endless source of wonder, a gentle invitation to let our minds wander freely, unburdened by the need for definitive answers. The gentle hum of the quantum vacuum, the slow dance of time and now, the infinite whisper of other universes. These profound concepts are not meant to cause anxiety or intellectual strain. They are simply invitations to float, to wonder, to release the tension of the known, and embrace the comforting mystery of the unknown. Rest in the vastness of this idea. Your universe, your life, is part of something infinitely grander, something endlessly creative. You are held within a boundless embrace of possibilities, a cosmic lullaby sung across countless dimensions. Having gently floated through the concept of countless universes, let us now bring our awareness back closer to home, yet still within the realm of the profoundly mysterious. We turn our quiet contemplation to a concept that underpins the very fabric of our reality, yet remains largely unseen: dark matter. Imagine the universe as a grand cosmic symphony, filled with the visible light of stars and galaxies, a dazzling performance we can observe and admire. But what if there was an entire orchestra playing in the shadows, its presence felt through its profound influence, but its instruments and musicians remaining utterly invisible to our eyes? That, in essence, is the enigma of dark matter. For decades, scientists observed that galaxies were spinning too fast. If you look at a spiral galaxy, like our own Milky Way, stars on the outer edges are orbiting at speeds that should cause them to fly off into the emptiness of space, much like a ball swung on a string would if the string wasn't strong enough. Yet, they don't. They remain gracefully bound within their galactic dance. This suggests that there must be much more gravitational pull, much more mass than what we can see. The visible stars, gas, and dust simply aren't enough to hold these galaxies together. This invisible, undetected mass is what we call dark matter. It's a beautiful paradox, isn't it? Something that exerts a powerful influence, shaping the very structure of the cosmos, yet remains completely hidden from our instruments. It doesn't emit, absorb, or reflect any light or electromagnetic radiation, which is why it's dark. It's not dark in the sense of being black, but dark in the sense of being invisible to all our telescopes, whether they see visible light, X-rays, radio waves, or anything else across the electromagnetic spectrum. Think of it as the universe's quiet, unseen scaffolding. Without this invisible support, galaxies wouldn't form the way they do. They would unravel. Galaxy clusters, those vast gatherings of thousands of galaxies, would not hold together. The large-scale structure of the universe, the intricate cosmic web of filaments and voids that stretches across billions of light years, would not exist in its observed form without the gravitational embrace of dark matter. It is the unseen architect, shaping the grand design of the cosmos. Scientists estimate that dark matter makes up about 27% of the total mass energy content of the universe. That's a staggering amount when you consider that all the stars, planets, and everything else we can see and interact with what we call normal matter or baryonic matter only accounts for about 5%. The rest, the overwhelming majority, about 68%, is that mysterious dark energy we explored earlier, driving the universe's accelerating expansion. So, our visible world is merely a tiny, luminous fraction of a vast, mostly invisible reality. This can be a deeply humbling thought, inviting a profound sense of perspective. It reminds us that our perception of reality, even with all our advanced instruments, is inherently limited. There is so much more to existence than what meets the eye, so much more that operates in the unseen depths. This can be a soothing realization, releasing the pressure to comprehend everything, allowing us to simply rest in the vastness of the unknown. But what exactly is dark matter? This is the grand question that keeps physicists gently pondering. It's not just regular matter that's too dim to see, like faint planets or dead stars. We know this because its gravitational effects are far too widespread and too strong to be accounted for by ordinary, non-luminous objects. It also interacts differently with light and other forces than normal matter does. So, Scientists hypothesize it must be made of new, exotic types of particles, particles that don't interact with light or with the strong and weak nuclear forces, only with gravity. They are truly dark in every sense. Many candidates have been proposed, each with its own elegant possibilities, each a whisper of a potential answer. Perhaps the most popular candidate is a hypothetical particle called a weakly interacting massive particle, or WIMP. Imagine particles that are massive, perhaps many times heavier than a proton, but incredibly shy. They barely interact with anything else, passing right through ordinary matter without leaving a trace. Trillions of these particles could be flowing through you right now, completely undetected, like silent cosmic currents. If WIMPs exist, they would explain why dark matter clumps in halos around galaxies and interacts only gravitationally. Another intriguing possibility lies in axions, particles that are incredibly light, perhaps even lighter than a neutrino, and interact even more feebly than WIMPs. If axions exist, they might be remnants from the very early universe, born in the intense conditions of the Big Bang and now permeating all of space, a faint, ethereal presence. And then there's the possibility of sterile neutrinos, a hypothetical type of neutrino that doesn't interact with the weak nuclear force like their active cousins. They would be even more elusive, like phantoms gliding through the cosmic void, leaving only the subtle gravitational ripples of their presence. The search for dark matter particles is a quiet, painstaking quest. Scientists around the world are conducting experiments deep underground, shielded from cosmic rays, hoping to detect the extremely rare instance when a dark matter particle might just barely bump into a nucleus of ordinary matter, producing a tiny, fleeting signal. Imagine sitting in perfect silence, listening for the faintest whisper, the most subtle tremor that would reveal the presence of this invisible entity. It is a testament to human curiosity and perseverance. We haven't found a definitive answer yet. Dark matter remains one of the universe's most profound and persistent enigmas, and in that uncertainty lies a beautiful comfort. It reminds us that our understanding of reality is always evolving, always expanding. It's a gentle invitation to embrace the unknown, to feel the edges of our knowledge, and to appreciate the humility that comes with truly grand scientific questions. Consider the profound implications if dark matter is truly composed of these exotic, non-interacting particles. It suggests that the universe is far richer, far more diverse than we ever imagined. It's not just the stuff of stars and planets. It's also made of something fundamentally different, something that exists alongside us, through us, yet remains forever separate, a silent partner in the cosmic dance. This realization can be deeply soothing. It hints at a hidden layer of reality, a silent, pervasive presence that holds everything together. When you look up at the night sky, you see the luminous constellations, the distant galaxies. But now, you can also quietly imagine the vast, unseen halos of dark matter cradling those galaxies, shaping their elegant spirals, guiding their majestic movements. It's like listening to the unseen bass notes of the cosmic symphony, providing the fundamental rhythm without being overtly heard. Let your thoughts drift to this invisible scaffolding, this omnipresent yet elusive influence. It is a reminder that what we perceive with our limited senses is but a small fraction of the grandeur that surrounds us. There are depths to reality that remain hidden, and in that mystery, there is a certain peace. You are made of ordinary matter, the luminous stuff of stars, yet you are immersed in a universe where the invisible vastly outweighs the visible. This connection to the unseen, this quiet coexistence with the unknown, can bring a profound sense of belonging. You are part of this grand, intricate design, a small, radiant spark within an immense, mostly dark and wondrous cosmos. Allow the thought of dark matter to gently ground you, to remind you of the hidden forces at play, the quiet architects of cosmic structure. There is no need to grasp or understand it fully. Simply allow the idea to drift through your mind, like a soft cloud across a peaceful sky. In this moment of quiet contemplation, let your body relax, feeling the subtle presence of gravity, which itself is influenced by this unseen mass. You are supported, held within the universe's grand, invisible embrace. As the idea of dark matter, the unseen architect of cosmic structure, gently settles in your mind, let us now turn our quiet gaze to another profound enigma, one that exists everywhere and nowhere, a boundary beyond which our current understanding strains the event horizon of a black hole. Imagine, if you will, the deepest well imaginable, a cosmic abyss so profound that not even light, the swiftest traveler, can escape its gravitational pull once it crosses a certain point. That threshold of no return, is the event horizon. Black holes are among the most mysterious and awe-inspiring objects in the universe. They are born from the dramatic collapse of massive stars, or perhaps even from the chaotic density of the early universe. When a star much larger than our sun reaches the end of its life, it can no longer support itself against its own immense gravity. The core collapses inward, crushing itself into an incredibly dense point known as a singularity. And around this singularity, the fabric of space-time, that flexible blanket we spoke of earlier, becomes so intensely curved, so deeply warped, that it forms a cosmic trap. This warping is so extreme that it dictates a one-way journey. Once anything, be it a particle of light, a dust mote, or even a wandering star, passes beyond the event horizon, it is caught. It is forever drawn inwards towards the singularity, like a leaf caught in an unstoppable current. No matter how fast it travels, no matter what force it exerts, escape is impossible. The path inward is the only path available. This concept can be surprisingly peaceful in its absoluteness. It represents a boundary beyond which the rules we know so well seem to transform. It is a place where light itself, our ultimate messenger, is silenced, unable to carry information back to us. For anything beyond that horizon, time as we understand it, as it exists for us, effectively ceases to be. It's a point of no return, a gentle surrender to an irresistible force. Imagine being an observer far away from a black hole, watching something approach its event horizon. As the object gets closer, strange things begin to happen. Time for the object, from your distant perspective, appears to slow down. Its light, as it struggles against the black hole's immense gravity, becomes red-shifted, stretching to longer, redder wavelengths, eventually fading from view altogether. It's as if the object freezes at the very edge of forever, a silent, fading memory. This phenomenon is a beautiful testament to the extreme warping of space-time around a black hole. But what would it be like to actually cross an event horizon? This is where our imagination truly takes flight, guided by the whispers of physics. From the perspective of the object crossing, nothing particularly dramatic would happen at the moment of crossing itself. There's no physical barrier, no wall, no sudden jolt. It's a smooth, continuous passage. However, once inside, the future, for that object, lies solely in the direction of the singularity. All paths lead inward. This journey inward, though smooth initially, would quickly become one of extreme distortion. As you approach the singularity, the gravitational pull on your feet would be vastly stronger than on your head, stretching you out like spaghetti in a process delightfully known as spaghettification. But, for the purposes of our gentle contemplation, let us focus not on the dramatic end, but on the profound boundary itself, the event horizon. The event horizon is not a physical surface, It's a sphere in space-time, a mathematical boundary. It's a bit like the horizon on Earth. When you look out at sea, the horizon seems like a line where the sky meets the water, but it's not a physical place you can reach and stand on. It's simply the limit of what you can see from your current position on the curved surface of the Earth. Similarly, the event horizon is the limit of visibility and escape in the curved space-time around a black hole. This idea of a boundary, both absolute and invisible, can be deeply calming. It reminds us that there are limits to our perception, that not everything can be seen or experienced directly. There are realms of existence that unfold according to different rules, beyond our immediate reach, inviting a sense of humble acceptance and quiet wonder. Supermassive black holes, residing at the centers of most galaxies, including our own Milky Way, are particularly fascinating. Our own galaxy hosts Sagittarius A, pronounced a star, a supermassive black hole with a mass of about 4 million suns. Imagine this colossal entity quietly sitting at the heart of our galaxy, its event horizon stretching for millions of kilometers, gently influencing the orbits of stars around it. It is a silent, powerful anchor for our cosmic home. These supermassive black holes grow by accreting gas and dust, and sometimes by merging with other black holes. When they actively feed, the matter swirling around them heats up to incredible temperatures, emitting powerful X-rays and gamma rays, making them visible as quasars or active galactic nuclei. These are some of the brightest objects in the universe, shining like cosmic lighthouses across billions of light years, remnants of a time when the universe was younger and more chaotic. But the black hole itself, the region beyond the event horizon, remains utterly dark, a silent testament to the extreme curvature of space-time. It is a place where information, in the conventional sense, is lost to our universe. This information paradox is one of the deepest puzzles in physics, raising questions about whether information is truly destroyed within a black hole, or if it somehow escapes in a form we don't yet understand, perhaps through the subtle radiation predicted by Stephen Hawking, known as Hawking radiation. Hawking radiation suggests that black holes are not entirely black. Due to quantum effects at the event horizon, virtual particle pairs, those fleeting particles of the quantum vacuum we discussed, can sometimes have one particle fall into the black hole while the other escapes, carrying away a tiny bit of the black hole's energy over an incredibly long time. This process would cause black holes to slowly evaporate, gently diminishing until they vanish entirely. Imagine a black hole, not as an eternal abyss, but as a slow, patient exhalation, gradually releasing its grip on space-time. This process, though unimaginably slow for stellar and supermassive black holes, paints a picture of even these ultimate cosmic prisons having a finite lifespan, eventually returning their borrowed energy to the universe. It's a comforting thought, suggesting that even the most formidable forces eventually yield to the subtle whispers of quantum reality. This gentle evaporation, this slow fading, means that even in the ultimate cosmic trap, there is a hint of release, a quiet dissolution. It reminds us that all things in the universe are in a state of flux, a perpetual dance of creation and transformation, even at the most extreme edges of existence. So, as you rest, allow your mind to gently contemplate the event horizon. It is a boundary, not of space, but of knowability, a threshold of profound mystery. It represents a surrender to an overwhelming force, a journey into the deepest curves of space-time. Feel the profound stillness that this concept evokes. The black hole, in its silent, gravitational embrace, draws everything into its depths, removing it from our visible universe. Yet, it is also a fundamental part of the cosmic tapestry. a testament to the extreme wonders that physics unveils. There is a peace in acknowledging these ultimate boundaries, these places where our conventional understanding dissolves. It's an invitation to let go of the need for perfect clarity, to simply allow the vastness and strangeness of the cosmos to wash over you like gentle waves upon a shore. You are safe, here in your own space, far from any event horizon. Yet, the principles that govern these cosmic behemoths are the same principles that subtly shape the reality around you. Let this grand scale, this deep mystery, soothe your mind, calming any restless thoughts. In this quiet moment, you are merely an observer, a gentle contemplator of the universe's most profound secrets. The event horizon stands as a silent sentinel, a reminder of the infinite depths yet to be understood, and the beautiful humility that comes with such profound questions. Relax, breathe deeply, and let thoughts of the vast universe lull you into a peaceful sleep. Every mystery is a gentle whisper, an invitation for your mind to wander in the vast silence. As the profound image of the event horizon, that silent threshold of no return, gently recedes from the forefront of your mind, let us now turn to a concept that both challenges and expands our understanding of cosmic history: the cosmic web. Imagine the universe not as a uniform, scattered collection of galaxies, but as a vast, intricate, three-dimensional network resembling the delicate strands of a spider's web, or perhaps the complex structure of a human brain. This is the cosmic web, the largest known structure in the universe, a silent testament to the gentle, persistent pull of gravity over billions of years. From our vantage point, looking out into the night sky, we see countless galaxies. For a long time, it was thought they were distributed relatively evenly, like sprinkles on a cosmic cake. However, as telescopes peered deeper and wider, a more intricate pattern began to emerge. Galaxies are not alone. They cluster together in magnificent groups, forming superclusters. These superclusters, in turn, are not isolated islands, but are connected by vast filamentary structures, long, thin strands of galaxies and gas that stretch for hundreds of millions of light years. In between these filaments lie enormous, empty regions, vast cosmic voids, where very few galaxies are found. This immense interconnected structure of filaments, clusters, and voids is the cosmic web. It's the skeleton of the universe, the grand framework upon which all visible matter is draped. It's a structure shaped primarily by the invisible hand of dark matter. Remember how we gently explored dark matter's elusive nature. It doesn't interact with light, but its gravitational pull is immense. It is believed that the cosmic web is essentially a map of where dark matter is densest. The dark matter formed the initial scaffolding, and then ordinary matter, the gas, dust, and galaxies we see simply fell into its gravitational embrace, tracing out the invisible pathways. Imagine, if you will, the early universe, soon after the Big Bang. It was almost perfectly smooth, but with tiny, subtle fluctuations in density, like imperceptible ripples on a vast, calm ocean. Over billions of years, gravity, that tireless sculptor, began to amplify these tiny differences. Regions that were slightly denser began to attract more matter from their surroundings. This process was incredibly slow, almost imperceptible over human timescales, but relentless over cosmic eons. As matter accumulated, it didn't just form isolated clumps. Instead, it flowed along preferred pathways, drawn towards the densest knots and strands. Think of water flowing down a gently sloping landscape, naturally forming streams, then rivers, and finally pooling in lakes. In the cosmic web, the streams and rivers are the filaments, guiding galaxies towards the lakes and nodes, which are the massive galaxy clusters. The dry lands between these flows are the vast, empty voids, This elegant organic structure can evoke a profound sense of interconnectedness. It suggests that nothing in the universe is truly isolated. Every galaxy, every star, every atom, including those within you, is part of this grand cosmic network. We are all connected, directly or indirectly, through these vast, invisible threads of gravity and dark matter. The largest individual structures identified within this cosmic web are astonishing. We're talking about structures that span over 1 billion light years, containing thousands of galaxies. Think of the Great Wall of Hercules' Corona Borealis, a supercluster complex that stretches for an incredible 10 billion light years across. These immense structures, however, are simply larger nodes and filaments within the even grander, overarching cosmic web. This realization can be deeply humbling and liberating. It reminds us of our place within an unimaginably vast and intricately organized cosmos. We are not just on a planet orbiting a star in a galaxy. We are part of a colossal cosmic brain, a neural network of galaxies connected by unseen pathways. Studying the cosmic web helps scientists understand the evolution of the universe from those early, smooth beginnings to the complex, structured cosmos we see today. It reveals how galaxies formed and grew, how superclusters assembled, and how the mysterious dark energy might be influencing the expansion of these large-scale structures, gently pulling them further apart, stretching the filaments and enlarging the voids. The voids, those vast, empty regions, are also a crucial part of the web. They are not entirely empty, of course. They still contain some galaxies and gas, but at much lower densities than the filaments and clusters. These voids are the cosmic deserts, regions where gravity's pull was weakest, where matter was gently pushed away towards the denser areas over cosmic time. They represent the quiet, sprawling emptiness that balances the grand structures of the web. Imagine floating in one of these voids. The nearest galaxy might be hundreds of millions of light years away, a faint, distant glimmer in the overwhelming darkness. It would be a place of profound solitude, of ultimate quiet, a testament to the universe's incredible scale and variety. Yet, even in the voids, the subtle influence of the cosmic web's gravity, shaped by dark matter, would be gently at play. The cosmic web is not static. It's a dynamic, evolving entity. Galaxies are constantly moving along the filaments, flowing towards the denser knots, driven by the gravitational currents of dark matter. This continuous, slow dance of cosmic structures paints a picture of a universe that is always in motion, always transforming, always gracefully rearranging itself. This can be a deeply calming thought. It suggests that change and flow are inherent to the universe's nature, from the smallest quantum fluctuation to the largest cosmic structures. Just as your own life is a continuous flow of moments and changes, so too is the universe a grand, evolving narrative, always moving, always becoming. Allow yourself to feel this profound interconnectedness. You are a part of this cosmic web, spun from the same material, governed by the same forces. The atoms in your body were forged in ancient stars, which themselves are part of galaxies, which are woven into the filaments of this grand, unseen structure. You are a tiny, yet essential thread in the universe's boundless tapestry. In this moment of quiet contemplation, let your thoughts drift along these cosmic filaments, seeing galaxies as shimmering pearls strung upon invisible threads. Feel the gentle, gravitational embrace that holds everything together, from the smallest dust motes to the largest superclusters. There is a deep peace in realizing that even in the vastness, there is structure, there is order, there is a magnificent design that unfolds with gentle, inexorable precision. The cosmic web is a silent symphony of gravity, playing out across billions of years, creating the universe we inhabit. Rest deeply in this understanding. The universe is not a chaotic explosion, but an intricately woven dance. You are part of this dance, a gentle participant in the cosmic web, eternally connected to everything that exists. Let this profound sense of connection soothe your mind and guide you into a state of deep tranquility. Let your mind float, light as a speck of cosmic dust, drifting on the threads of this web. The vastness and order of the universe will lull you into a peaceful sleep. As the vast, intricate patterns of the cosmic web gently recede into the peaceful depths of your mind, let us now turn our quiet contemplation to a realm of existence that defies our everyday intuition, a place where reality itself seems to shimmer and fragment the quantum realm. Imagine, if you will, shrinking down, smaller and smaller, past the familiar world of atoms and molecules, beyond the tiny nucleus, until you reach a scale so infinitesimally minute that the very laws of physics as we know them begin to blur and transform. This is the quantum realm, the fundamental bedrock of all that exists, a place of profound mystery and astonishing beauty. In our macroscopic world, the one we inhabit, things behave in predictable ways. A ball thrown follows a clear trajectory. A light switch is either on or off. Objects have definite positions and definite speeds, but in the quantum realm, at the scale of electrons, photons, and other subatomic particles, these certainties vanish. Here, particles behave in ways that seem utterly counterintuitive, defying our common sense, yet forming the very foundation of all reality. One of the most mind-bending aspects of the quantum realm is the concept of wave-particle duality. Imagine a tiny entity, like an electron or a photon. Is it a particle, a tiny, discrete dot of matter, or is it a wave, spread out through space, like a ripple on a pond? The astonishing truth is that it can be both, depending on how you observe it. Sometimes it acts like a definite particle located at a specific point. Other times, it behaves like a wave, able to pass through multiple places at once. It's like a whispered secret that changes its nature depending on who is listening. This duality means that these fundamental building blocks of the universe do not have a fixed, unchanging nature until they are observed or interact with something. Until then, they exist in a hazy state of potential, a superposition of all possible states simultaneously. Consider the famous Schrödinger's cat thought experiment, a playful yet profound illustration of this idea. Imagine a cat in a sealed box with a device that has a 50% chance of releasing a deadly poison based on a quantum event. According to quantum mechanics, until you open the box and observe the outcome, the cat is neither dead nor alive. It exists in a superposition of both states. Only upon observation does the wave function collapse, and the cat becomes definitively dead or alive. This concept can be deeply unsettling to our logical minds, yet it reveals a profound truth about reality at its most fundamental level. Reality is inherently probabilistic and fluid. Things don't just exist in one state. They exist in a cloud of possibilities until interaction or observation brings them into being. This idea of a probabilistic, fluid reality can be surprisingly calming. It suggests that nothing is entirely fixed, that potential is woven into the very fabric of existence. Every moment holds a multiplicity of possibilities, gently unfolding based on subtle interactions. It removes the pressure of absolute certainty, inviting us to embrace the inherent openness and dynamism of the universe. Another fascinating quantum phenomenon is quantum entanglement. Imagine two tiny particles that become intertwined in a special way, no matter how far apart they are. If you measure a property of one particle, say its spin, the other entangled particle instantly takes on a correlated property, even if they are light years apart. It's as if they share a secret, instantaneous connection, communicating across the vastness of space without any apparent medium. Einstein famously called this spooky action at a distance. This instantaneous connection seems to defy our everyday understanding of locality, where things only affect their immediate surroundings. But entanglement is a confirmed reality, a cornerstone of quantum mechanics. It suggests a deeper, more profound interconnectedness in the universe than we can easily grasp. This can be a deeply peaceful thought. If particles, no matter how distant, can share such an intimate, instantaneous bond, then perhaps everything in the universe is, at some fundamental level, interconnected. Your very being, the atoms that make up your body, might be subtly entangled with the stars, with distant galaxies, with the very fabric of space-time. It whispers of a cosmic unity, a gentle reminder that you are not isolated, but part of an infinitely interwoven whole. The quantum realm also introduces the idea of quantum tunneling. Imagine a tiny particle approaching a barrier, like a small hill. In our classical world, if the particle doesn't have enough energy to go over the hill, it simply can't pass. But in the quantum realm, there's a tiny, non-zero probability that the particle can simply tunnel through the barrier, appearing on the other side as if by magic, even without the necessary energy. This bizarre phenomenon is not just theoretical, it's essential for life as we know it. For instance, it's how nuclear fusion occurs in the sun, generating the energy that warms our planet. Protons in the sun's core don't have enough energy to overcome their mutual repulsion and fuse, but quantum tunneling allows them to tunnel through this electrostatic barrier, enabling the fusion process. This quiet miracle of quantum tunneling reminds us that the universe is full of hidden pathways, unexpected possibilities. Even in the face of seemingly insurmountable obstacles, it suggests a subtle, inherent flexibility in reality, a gentle ability to find new ways to manifest, defying classical expectations. This understanding can be deeply calming. It whispers that even when faced with seemingly impossible barriers in your own life, there might be unseen quantum tunnels, unexpected paths that allow for breakthrough and transformation. It encourages a gentle openness to the improbable, a quiet faith in the universe's surprising ways. The quantum realm is where the empty vacuum is alive with virtual particles, where matter exists as waves of probability, and where particles can be intimately connected across vast distances. It is the realm of the fundamental, yet it remains shrouded in its own unique form of mystery. We can describe its behavior mathematically, but truly visualizing or fully intuiting it challenges the very limits of our human understanding. And in that challenge, there is a profound peace. It reminds us that there are depths to reality that transcend our grasp, that the universe is far stranger and more beautiful than we can ever fully comprehend. It invites us to release the need for absolute control or complete understanding, and instead to simply rest in the awe-inspiring wonder of what is. Let your mind drift gently into this quantum landscape. Imagine the atoms that make up your body, the electrons that shimmer around their nuclei, the photons of light that gently touch your skin. Each is a tiny symphony of quantum possibilities, existing in a dance of waves and particles, entanglement and tunneling. You are a macroscopic expression of this wondrous, probabilistic, fluid reality. Feel the subtle vibrations of existence at its most fundamental level. There is a deep, underlying hum of potential, a quiet, ceaseless activity that forms the very fabric of being. In this gentle hum, you can find a profound connection to all things, a sense of belonging to the universe at its most intricate and mysterious level. There is nothing to force, nothing to figure out. Simply allow the concepts of wave-particle duality, quantum entanglement, and quantum tunneling to softly resonate within you. They are not problems to solve, but invitations to wonder, to let your imagination expand into the infinite richness of reality. Rest now in the knowledge that even at its core, the universe is a place of beautiful uncertainty, profound connection, and hidden pathways. This quiet, quantum dance is always unfolding, gently cradling your existence. Let your thoughts drift away, and let these profound concepts gently lull you to sleep. You are part of the quantum universe, a miracle of existence. As the elusive dance of the quantum realm gently fades from your quiet contemplation, let us now turn our awareness to an even grander concept, one that encompasses all the vastness we've considered so far, the shape of the universe itself. Imagine, if you will, being able to step outside of our cosmic bubble and see its overall form. Is it flat and infinite, gently stretching forever in every direction? Is it curved like a giant sphere, perhaps allowing you to eventually return to where you started if you traveled far enough? Or is it something more complex, a subtly curving, hyperbolic shape that diverges endlessly? These aren't just abstract mathematical curiosities. They are profound questions about the very nature of existence. How the universe is shaped influences its ultimate fate, how light travels through it, and even whether it is finite or truly infinite. And in this quiet space, we can gently explore these possibilities without needing to grasp their full, intricate details. The question of the universe's shape is deeply tied to its geometry and its density. Imagine a vast, two-dimensional surface. If this surface were perfectly flat, like a perfectly stretched sheet, then any two parallel lines drawn on it would remain parallel forever, never converging or diverging. Triangles drawn on this surface would have angles that sum precisely to 180 degrees. This is called flat geometry, and it represents a universe that is either infinite in extent or, if finite, wraps around itself in a very specific, topologically complex way. If the surface were curved like the surface of a giant sphere, then parallel lines would eventually converge. Imagine drawing two parallel lines on the surface of Earth. If you start them both pointing north from the equator, they would appear parallel, but they would inevitably meet at the North Pole. Triangles drawn on this spherical surface would have angles that sum to more than 180 degrees. This is called positive curvature, or closed geometry, and it describes a universe that is finite in size, eventually curving back on itself, like a cosmic loop. If you were to travel in a straight line in such a universe, you would eventually, after an immense journey, return to your starting point, perhaps even seeing the back of your own head if you could look far enough back in time. Finally, if the surface were shaped like a saddle or a Pringle chip, then parallel lines would diverge, moving further and further apart. Triangles drawn on this surface would have angles that sum to less than 180 degrees. This is called negative curvature or open geometry, and it describes a universe that is truly infinite in extent, expanding outward forever in every direction, with space constantly spreading out faster and faster. So, which of these shapes is our universe? This is where the universe's density comes into play. The total amount of matter and energy in the universe dictates its curvature. There's a critical density, a magic number. If the universe's density is exactly equal to this critical density, then its geometry is flat. If its density is greater than the critical density, it's positively curved, like a sphere. If its density is less than the critical density, it's negatively curved, like a saddle. For decades, scientists have been carefully measuring the universe's density. They look at the visible matter, the dark matter, and that mysterious dark energy we explored earlier, adding it all up. And the results, from observations of the cosmic microwave background, that ancient whisper of the Big Bang and the large-scale structure of the cosmic web, strongly suggests that our universe is remarkably, almost perfectly, flat. Imagine, then, our universe as an endlessly unfolding, perfectly smooth canvas. It stretches outward, silently, without any discernible edge or boundary that we can perceive. This flatness is a profound finding, hinting at an almost elegant simplicity in the universe's grand design. This idea of a flat, possibly infinite universe can be deeply soothing. It suggests an endlessness of possibility, a boundless expanse that continues forever. There are no walls, no ultimate barriers, only continuous unfolding. It removes any sense of claustrophobia, inviting a profound freedom of thought and imagination. However, even if the universe is flat, its overall size is still debated. Is it truly infinite, stretching forever in every direction? Or is it flat but finite, like the surface of a torus, a donut shape which is locally flat but has no edge and wraps back on itself? The current observations simply tell us that it's flat on large scales, meaning that if there is any curvature, it's so gentle and so vast that we haven't been able to detect it within the observable universe. It's like standing on a tiny patch of Earth and thinking it's flat, while knowing it's part of a much larger curved sphere. But in the case of the universe, that larger sphere might be so enormous that it's practically flat within our observable reach. The universe's flatness also strongly supports the theory of cosmic inflation. Remember that super rapid expansion in the very early universe. If inflation truly occurred, it would have stretched any initial curvature of space-time so dramatically that it would appear flat to us today, much like inflating a tiny wrinkled balloon to an enormous size would make any small wrinkles appear smooth and flat on its surface. So, the flat universe we observe is a beautiful confirmation of that fleeting, powerful moment in cosmic history. This connection between inflation and the universe's flatness weaves together several threads of our cosmic story, revealing a deeper harmony in the universe's evolution. It suggests that the immense, rapid growth of the very early universe left an indelible mark on its overall shape, a gentle, lasting impression of its fiery birth. Contemplating the universe's flat shape can bring a sense of profound stability. It's not collapsing in on itself, nor is it expanding with an explosive, uncontrolled divergence that we can detect in its overall geometry. Instead, it unfolds in a remarkably balanced and smooth manner, a steady and perpetual expansion, carrying galaxies further apart like silent, drifting ships. Imagine this vast, flat plane stretching out infinitely, containing all the dark matter, dark energy, and visible galaxies we've discussed. Every celestial object, every cosmic structure finds its place upon this boundless canvas. The cosmic web, with its filaments and voids, is painted across this flat expanse, a testament to its fundamental geometry. There is a peace in this grand, simple form. It suggests a universe that is both orderly and endless, a place where the laws of physics consistently apply across unimaginable distances. It invites a quiet acceptance of its sheer scale and a profound sense of awe at the elegance of its design. Allow your mind to gently encompass this idea of a flat, boundless universe. Feel the sense of openness, of endless possibility. There is no edge to fall off, no barrier to hit, just continuous, gentle expansion, carrying you along in its silent, majestic flow. In this quiet contemplation, you are floating within a universe of immense proportions, a universe that, to the best of our current knowledge, appears perfectly balanced, perfectly flat. This understanding can bring a deep sense of serenity, a feeling of being cradled by an endless, harmonious cosmos. Let your mind wander in this limitless vastness, feeling the balance and order of the calm universe. All worries will fade away, giving way to peaceful sleep. As the vast, flat expanse of the universe gently settles in your imagination, let us now turn our quiet attention to a concept that explores the very beginning of everything, yet hints at a reality far more profound than a simple start, the idea of a universe without a boundary. This is a notion championed by profound thinkers like Stephen Hawking, a way to reconcile the Big Bang with the deeper mysteries of what might have existed before, or if before even makes sense. Imagine, if you will, a journey. You decide to walk north from wherever you are. You keep walking, always north. What happens? Eventually, you reach the North Pole. But what is north of the North Pole? The question itself loses meaning. There is no further north. You can only begin to travel south. The North Pole is a boundary in terms of direction, but not an edge of the Earth itself. The Earth's surface is finite, yet it has no boundary, no sharp edge where it suddenly stops. It smoothly curves back on itself. Now, apply this gentle analogy to the universe, not just in space, but in time. The traditional Big Bang model describes the universe bursting forth from an incredibly hot, dense singularity. This singularity feels like a definite beginning, a point beyond which our laws of physics break down, leaving us with the unanswerable question, what happened before? It's like asking what's north of the North Pole, but for time itself. The no-boundary proposal suggests that if you go far enough back in time, approaching the earliest moments of the universe, the arrow of time, that relentless forward march we discussed begins to blur. It's as if time itself becomes more like space, curving around smoothly, rather than hitting a sharp edge or a singular point. In this view, the universe didn't begin in a conventional sense at a singular point in time. Instead, it emerged from a state that resembles the surface of a sphere, where there is no definite starting point, just a smooth, continuous curvature. Imagine, not a sharp cone for time's beginning, with a definite tip marking the start, but rather a smooth, rounded cap, like the surface of a perfectly formed tiny sphere. As you trace back along this surface, you never hit a point where time suddenly springs into existence. Instead, it simply curves around, like the surface of the Earth. This idea is deeply rooted in quantum mechanics and the search for a theory of quantum gravity, which seeks to describe the universe at its most fundamental, where space-time itself is subject to the strange, probabilistic rules of the quantum realm. At the extreme energies and densities of the very early universe, gravity becomes so strong that quantum effects dominate. In this quantum gravity regime, the classical idea of a fixed, definite timeline might simply not apply. Instead, the no-boundary proposal suggests that the universe, in its earliest, quantum-dominated moments, existed in a kind of imaginary time that is indistinguishable from space. It's a highly mathematical concept, but the essence is beautifully simple. If time behaves like another spatial dimension in the very early universe, then it, too, can be finite but unbounded. Just like the surface of a sphere, there's no moment when time begins, because the concept of time as a linear progression from past to future hasn't fully emerged yet. This can be a profoundly calming thought. If there's no actual boundary to time, no sharp cutoff point, then the universe didn't spring from nothingness in a way that needs an external cause. It simply is. It's self-contained, complete within itself. The question of what was before the Big Bang becomes as meaningless as asking what is beyond the Earth's surface if you're traveling on it. This interpretation offers a gentle resolution to one of the most persistent philosophical puzzles about the universe. It invites us to release the need for a creation event that requires something outside the universe to kick it off. Instead, the universe gracefully emerges from its own inherent quantum nature, without a true start or end in the way we usually conceive them. Think of it as the universe being a complete, self-existing entity, always having been in a state of potentiality, gradually unfolding into the space-time we experience. It's like a cosmic story that has no first page, only an ongoing narrative that curves back on itself endlessly. This idea challenges our deeply ingrained linear perception of time, which might be just an emergent phenomenon, a feature that becomes apparent only after the universe expands and cools enough for classical physics to take over. In the earliest, hottest, most quantum-dominated moments, the distinction between time and space might have been blurred, leading to a universe that is boundless in all directions, including the temporal one. The implications for our sense of existence can be deeply profound and soothing. If the universe has no boundary, if it is fundamentally self-contained and complete, then so too, perhaps, is our own existence within it. We are not isolated, fragile beings cast into a void that appeared from nowhere. Instead, we are an intrinsic part of a timeless, boundless reality, eternally connected to its deepest origins. Allow your mind to gently encompass this idea of a universe without a beginning or an end in the conventional sense. Let the sense of a smooth, continuous curvature in both space and time wash over you. There is no initial push needed, no ultimate stop, just an elegant, self-consistent existence. This view can bring a deep sense of peace, a feeling of being eternally cradled within a universe that simply is. The Big Bang, from this perspective, is not an initial event from absolute nothingness, but rather the point from which the universe began to expand and cool into the form we recognize, a natural unfolding from a prior, unbounded state. You are a part of this endless, boundless reality. Your consciousness, your very being, is interwoven with a universe that had no distinct starting point, and perhaps no ultimate end. It's a continuous flow, a perpetual becoming. Rest now in the quiet contemplation of a universe that is complete within itself, boundless in its fundamental nature. Let this profound sense of continuity and self-existence soothe your thoughts and gently lead you into a deep and peaceful slumber. Allow your mind to perceive the continuity and infinity of the universe, where there is no clear beginning or end. You are part of this eternal flow. As the profound idea of a universe without a boundary gently envelops your awareness, and the whispers of its timeless, self-existent nature soothe your mind. We approach the quiet conclusion of our shared journey. We have drifted through the fiery dawn of the Big Bang, felt the intricate flow of time, pondered the vibrant stillness of the quantum vacuum, imagined the boundless expanse of the multiverse, traced the unseen threads of dark matter and the majestic cosmic web, and contemplated the absolute threshold of a black hole's event horizon. Each concept, a doorway to deeper wonder, a gentle invitation to let your mind roam freely in the vast, beautiful tapestry of existence. You have allowed your curiosity to be a soft guide, leading you not to rigid answers, but to a deeper appreciation for the grand, unfolding mysteries that define our cosmos. There has been no pressure here, no urgency to grasp every detail, only the peaceful freedom to simply listen, to imagine, and to feel the profound interconnectedness of all things. Remember that the universe, in all its astonishing complexity and immense scale, is also a place of fundamental simplicity. It is a place of rhythms and flows, of subtle energies and unseen forces, all dancing together in a continuous, elegant ballet. And you, in this very moment, are an intrinsic part of that dance, the stardust that makes up your being, the energy that animates your thoughts, the consciousness that allows you to wonder, all are echoes of that initial cosmic dawn, interwoven with the fabric of space-time, touched by the quantum realm, and cradled within the vast, beautiful design of everything. As we gently bring our journey to a close, let any lingering thoughts, any small worries, simply drift away like distant stars fading into the quiet dawn. There is a deep peace in realizing how much we are connected to the boundless universe, how every scientific concept, no matter how abstract, ultimately speaks to the profound reality of our existence within it. You are held. You are part of an unimaginable grandeur. You are a miracle of cosmic unfolding. Allow the gentle hum of these vast ideas to become a lullaby, a soft whisper guiding you deeper into rest. There is no need for anything more than this quiet presence, this profound stillness. All questions can now rest. All seeking can now cease. Just peace. Just being. This exploration has been a journey for your mind to wander freely, a space for quiet contemplation and relaxation. It is not intended to provide medical advice, nor should it replace professional therapy or treatment for sleep disorders or any health conditions. Always consult with a qualified healthcare provider for any health concerns. Sleep tight and dream sweet dreams, where the vast universe will be your companion. May you have a peaceful night and wake up with a peaceful mind.